perhaps for orientation purpose, it might be good to refer to the green schedule to get an idea of what's happening this afternoon. The afternoon session is devoted to a series of presentations by practitioners in the state, design practitioners. The rationale for the particular format was that it was very easy to identify a number of practitioners in the state of Indiana that are actively involved in designing solar or energy conscious projects in the state. And it seemed very reasonable to share the podium with those practitioners in the state who are showing some leadership in this field. We do have the out-of-town experts who can come in and tell us what's happening in other parts of the country, but there seems to be nothing quite as believable as the practitioner next door who was somehow able to make it work in Indiana. That always has an extra element of clarity and convincingness to it. Let me identify the panel that's on the right, the people who will not be sharing the podium. We have Bill Kinst, who is a former faculty member at CAP and who's been long involved in the energy picture. We have Michael Adsit from the Solar Store, Peoria, Illinois. John Purcell, whom you've met and heard earlier. They will be here as resource people to field questions that the speakers may want to relay to them. So the basic format is that the speakers, the professionals, will be presenting projects that they have been involved with, energy and solar related. There will be a time at the end of their presentation for questions and answers. And the panel on the right can assist in that. Without further ado, let me introduce Mr. William C. Moe, AIA, the Vice President of Cole Associates Incorporated, South Bend, Indiana. And the project that he will be discussing is their own office building, which is just recently completed, and from an energy point of view, I think a very interesting project. Mr. Moe.
Thank you. I just would like to take a few minutes to explain or 90 people who occupy this building. Okay. So with that in mind, then you'd have to understand what happens when an AE firm decides to design their own building, and let me say it's very difficult. With several architects on the staff, you cannot really design a good building by that large a committee. Our approach to it was to assign the project to a project architect on the staff who then would treat the firm then as a client and carry on from that point. He survived very well, and I asked him to make this presentation today because he was so involved with all of the design decisions. Jim Wicks is a graduate architect at the University of Illinois, has been on our staff for about 8 or 9 years, and he has written the presentation and put together this slide presentation today. So I will ask Jim Wicks then to make the presentation of our new corporate office building, and we'll get done with it and answer your questions.
Thank you. Unaccustomed as I am. I did survive. It wasn't that terrible an experience, and Mr. Moe was actually very involved with it, as well as many other people in the firm. It's not a one-man show by any means. The site selected for the office building was 3 acres in area. I think I need the lights off. Thank you. It's just magical. This is fantastic. The site selected, as I said, was 3 acres in area, thickly covered with brush in some areas, and containing a large house, its lawn, and a garden. The site faces Jefferson Boulevard, a main arterial thoroughfare, and is part of an area of mixed use, including single-family dwellings, a school, a church, a hospital, and apartments in the immediate neighborhood. What I'm trying to say is that the context was a very mixed bag for this project. The structure encloses approximately 27,940 square feet on 2 levels. The lower depressed 1/2 level into the ground, the upper raised 1/2 level. The building was intended to be highly visible. Escalation of the public's awareness of the firm was felt to be desirable, and the decision to use a strongly modeled volume and contrasting materials in subdued colors comes partially from this requirement. To increase the bulk of the building and to reduce the area it occupied on the site, it was determined to use a 2-story solution. We wished to avoid the lower levels becoming a basement, however, and raised the lower level until it was half exposed, the upper level being a 1/2 story above grade. The plan of the building is organized in 4 parallel zones. I don't know, can you read the print? Can you read the slide? Okay, good. I won't use the pointer then. Reading from bottom to top on the slide are the zones Executive, Galleria, Administration, and Production on the upper level. On the lower level, we have, again reading from bottom to top, Graphics and Lunch, Galleria, Library, Reproduction, Computer Spaces, and Storage Mechanical for the lower level. The raised platform of the upper level could be seen clearly during the construction. The central Galleria, or circulation space, rises through both levels to unite them and to reduce the impression of the lower level being depressed with its functions relegated to the basement. Much of this space is occupied by people doing daily office tasks, and we wanted to avoid the cellar syndrome for those people. The exterior of the completed building follows faithfully the intentions of the model and demonstrates its visual strength as well as its response to the need for solar control. These are slides of the east elevation, a corner detail, the main entrance to the building facing Jefferson, and the agony box entrance. At Cole Associates, we have found, as most other practicing professionals have, that our clients' awareness and understanding of what the energy crisis means to them is confined to their very accurate perception of how much more it takes to operate their buildings. Few, however, possess a grasp of ways to reduce their operating expenses, especially when it comes to using solar energy. In attempting to assist them in developing energy-efficient systems, we found that we ourselves needed, A, to have some first-hand knowledge of the systems we proposed or rejected, and B, to demonstrate our own faith in the utility of solar usage by putting our money where our mouth is. This building is our way of directly teaching ourselves about alternative energy and persuading our clients to listen to what we learn. During the schematic and design development phases of the project, we found that nearly everyone in the office felt that it was important for his or her workspace to have a view of the exterior, or at least some natural light. We used a questionnaire which all employees filled out and on which all employees were invited to respond with their own input to the project. As it became apparent that the organization of the internal functions precluded everyone's having an exterior exposure, the possibility of introducing natural light into the interior of the building via roof penetrations became the source of its solar response. Strongly contrasted interior and exterior expressions became a part of the design concept. The exterior visual weight and darkness of the building and the competent, conservative, professional qualities thus projected as its public image are relieved on the interior by drawing natural light as deeply as possible into the building, including the lower level and those offices without exterior exposure. An all-white color scheme ensures maximum reflectance from interior surfaces. Vertically glazed monitors allow not only control of solar gain and heat loss, but also enable exploitation of the variable qualities of sunlight's direction and intensity. Exterior offices are glazed with thermopane windows protected in deeply recessed openings with masonry piers to baffle unwanted horizontal illumination. Vertical sun angles are controlled by extending the masonry fascia edge downward in a series of suspended horizontal metal louvers or sunshades. They don't show in that photograph because they haven't been installed yet. I'm sorry, as the landscape has not been. Solar angles were calculated to prevent direct incident sunlight from occurring on glass surfaces of occupied spaces during working hours. During the winter, solar gain is used to reduce heat loss at the window surfaces. Interior offices are provided with generous borrowed light glazing strips above the 7-foot 4-inch height. The greater privacy of the office spaces is expressed by the elevation of the borrowed lights and reduced interior ceiling heights. All interior offices open directly into the large monitor-lighted spaces, and all are provided with borrowed light glazing. Of the 4 parallel zones of the building, 2 are greatly different in scale and function from the offices. The Galleria, shown here, and the drafting room. The need of these spaces, because of their larger dimensions, for higher ceilings, was aided by using monitors to allow visual extension of the interior volume to the sky. The Galleria was conceived as a central circulation space for the building and its main connection with the circulation movements of the outside world. This extension is expressed in the floor material, the use of large plants, and the introduction of natural light from the south, except above the upper walkway, where the direction of the monitors reverses to admit north light. South light has the most brilliance and direction, and therefore the best ability to penetrate to the lower level spaces. It was used to enliven the Galleria and create maximum interest. The drafting room has different requirements. High light levels with constant, even illumination are needed here. This is the largest space in the building, and monitors provide natural light across the whole depth of the room, in addition to the illumination afforded by perimeter windows. In this room, the synthesis of the building's response to the sun is seen. Over the drafting area, the monitors face north, admitting cool, indirect light, suitable and sufficient even for fine drafting board work. Recent readings at work surface height give an average of about 90 to 100 foot candles. Drama and excitement are not a part of this space. Deliberation and calm are in. The direction of the monitors changes for the east 5 feet to allow south light to enter, penetrate the offices on this side of the drafting room, and play across a white relief of openings and walls. All solar response has been passive so far. The exterior south-facing surfaces of the drafting room monitors are sloped at the recommended latitude plus 10 degrees to give a surface inclined at 53 degrees for the installation of flat plate collectors. 1,500 square feet of available collector area is intended for installation on these surfaces. In the slide they show white. The color that you see there is not the collectors, as I've mentioned. They're not installed at this point. But the roof surface of the monitors is white to aid in reflectance. Adjacent monitors are spaced so that lowest winter light will not shade the next collector, allowing maximum absorption during the time of year it is most needed. Based on a 50% efficiency factor, the calculated solar gain from the collector bank is 273,750,000 BTUs per year. This is equal to 80,000 kilowatt hours of electricity per year, and at 3 cents per kilowatt hour, the expected savings in equivalent electrical energy will amount to about $2,400 per year. To this must be added the as yet unknown amount of electrical energy eliminated by being able to turn off all artificial drafting room, galleria, and perimeter office lighting on sunny days. During the recent coal strike, we found that virtually normal operations could be maintained even in offices at the center of the building with only the occasional use of small task lights. All other building lighting was turned off. It quickly became apparent that the first cost of flat plate collectors at their current stage of development compared badly with their payoff time, which we calculated to be nearly 13 years. We calculate that the collector bank, once installed, will be able to heat all our hot water, provide fin tube radiation at the perimeter windows, temper outside air as it is drawn into the building, and reheat air being circulated back through the system from occupied spaces. Collector maintenance and repair costs are almost completely unknown at this time, but in the few instances known to us, seem to be high. These projections are based on current technology, and we fully expect them to improve as better hardware is made available. Economically, the fact that trade-off between solar energy and conventional energy sources will continue to improve as fuel costs keep rising, and the hope that solar hardware costs will decline comparatively as more units are produced by more manufacturers lead us to feel that the payback period will continue to become more favorable. We find a lack of information on what return on solar investments is reasonable. To find out, we are starting to monitor the building's behavior. Information will be gathered on heat losses and gains at glazed surfaces, overall heat gain loads on the building, heat generated by artificial lighting as compared to that gained or lost by glazed openings, percentage of days on which lights may be turned off in part or whole, and equivalent gas and electrical savings. In terms of professional liability, so much on our as well as your minds lately, we feel that our experimentation is happening in the right place, on our roof, not on that of one of our clients. May I have the lights, please? Good. Are there any questions or comments? Yes. The question was whether or not we intend to install the units on the roof within the next year or so, or to wait until the price becomes more economical. And the answer is to wait until the price becomes more economical. Not only that, but we also feel that we need to gather more information on how the building responds passively. And then when we do install the flat plate collecting bank, to design the installation in order to augment those parts of the passive response which we feel need support from the system. Yes?
It's been brought up several times today. One of our, roles for monitoring manufacturing flat plate collecting technology. And I've heard the comment made several times today about price reduction in solar equipment and flat plate collectors.
Right.
I've got, I guess, give my opinion, my professional about that comment, that I don't really believe it's going to happen. We're dealing with fairly standard type components, i.e. aluminum, copper, steel, glass, insulation. The only possible savings that I can see is possibly in terms of mass production, but already most of the manufacturers are contemplating fairly sizable price increases in their equipment at the levels they are right now, which are fairly expensive, high cost.
Oh, wow. This is to accommodate increases in production costs and raw material costs, or?
It's primarily reflecting increases in raw material costs. I feel that flat plate collectors are not going to increase as fast as a lot of other heat equipment because of the increase in spreading out the overhead manufacturing process.
Right.
It might hold you.
If I can comment on that statement, the cost factor would be influenced, of course, by the cost of fuel. Fuel cost
escalated substantially, which we are sure it will. Comparatively, the cost of the collectors would become less. It isn't a matter of a dollars and cents statement right now today.
I would agree.
Okay.
I'd like to add one bit to the cost problem that I'd like to include some discussion on, and that is, it is true that there is not likely to be any great reductions in first cost of collectors, but the real significant problem we're seeing in these systems is their rate of failure. And the cost implication is, when do they produce collectors that aren't going to fail?
So you see the problem of the long-term maintenance of such a system as being of considerable concern.
I think my recommendation to most of my clients is let's wait until the market stabilizes and we have a product that has some proven. And I can't blame the producers of these, because we don't have a reliable history on collectors as yet.
Right.
Until we've got, even you mentioned the problem of liability. And the courts are going to recognize something that's going to hold up for 5 or 10 years.
Mm-hmm.
Well, we don't. In many of these, we don't have that history yet.
I see.
So,
is it your feeling that the cost of these things, or the state of these things' development, flat plate collectors' development, is kind of already peaked? Have they become as efficient and as good as they can be? Obviously, we have an opinion here that they're not as long-lived as they probably ought to be.
Well, I think the efficiencies of flat plate collectors have somewhat climaxed to some degree. I don't believe there will be any any improvement in efficiency to speak of. I would agree with what was just said about the reliability of the systems. And we're dealing with an industry right now that has over 200 manufacturers. There are no set performance standards other than some recommended ASHRAE 9377 standards, and they're yet to be adopted, I think, on an industry-wide scale. And the other problem is really in the installation field, I think, where we're seeing the majority of the problems. We've got the trades who have been doing mechanical work for years and years, but all of a sudden we put the word solar on it and people get confused.
Yeah, they can't do it anymore.
The record of expansion tanks on the wrong side of the pumps, and pumps put in backwards, and check valves left out, and dampers not put in is just remarkable. And somehow that obstacle has been created there within the construction field, and there's no real reason for it other than a learning curve that's going to have to we're going to have to go through.
Right.
Our experience in the demonstration program has been that the collectors themselves have not failed as much as as Mike was saying, the system was not put in right. We've had a lot of that, and also we've had the people that operated it. Many of these that we have are schools, and they went home for Christmas and they left, just let it sit there, and they forgot all about it. The fact that you have to keep watching these things. So I think there's seems to be more problem with the system and with how to operate the system.
Excellent. Dan.
Have you been able to operate entirely on the basis of natural lighting?
Yes. Yes. Not. Oh. The question was, have we been able to operate entirely on the basis of natural light throughout the winter? I would have to say probably not throughout the winter. It's true that especially in the most interior offices, and these are the ones that are buried right smack dab in the very middle of the building, and on the lower level, and that in areas like that we have had to augment with some task light. It's true. The task light, however, has been confined to small units, localized at work stations, rather than ambient lighting as might normally be used. Certainly we've made considerable effort to keep the lighting as reduced as we possibly could. And we find that, as I said, during a real crisis time, just about everything was turned off. And people were cranking per normal. It was not that greatest a hardship on anyone. Yes. The question was, have we been able to monitor the cost of energy used in this building for the past 3 months of the winter as compared with our previous office? The answer is no. We have not yet found somebody to do all of that monitoring for us on a regular basis. And we haven't really decided yet quite what we want to monitor either.
Excuse me on that question. We were in rented space previously in a multi-use building, and it would have been very difficult to isolate the area that we occupy just for a comparative basis.
Yeah, that's true.
So when we built the building, we elected to judge it on its own from year to year, and we've only had 3 or 4 months experience in it. So we could not make that evaluation.
Yeah. The previous system also had a miserable mechanical arrangement, and it would have been an unfairly complimentary kind of comparison anyway, so it probably wouldn't have been much good. Yes?
Was it primarily the users in the building that caused you not to bury the whole building? Or was it a land use problem?
No, it was primarily the users' response to the questionnaires. I put a lot of credence in what was said by people about the kind of space they wanted to work in. I encouraged that kind of feedback. I did a considerable amount of talking with people about their responses. Sometimes we encouraged anonymity if it was desirable, but sometimes I could tell from people's handwriting, we're not that big an office, who had written what. And I would ask those people, how they really felt about what they wanted. We had talked for quite a while about moving our firm, and it had been on people's minds cooking and kind of incubating in an idea stage, but maybe not with the kind of communication the users might have wanted, the other employees might have wanted to experience, So I believe that the response to the glazing, of the building came directly from the people who use the building, as well as from the nature of the work that we do. I personally feel, and I believe it's borne out by some of the research being done by the behavioralists these days, that people who do little, close, concentrated kinds of work, writing, drafting, preparing reports and that sort of thing, typing, all that stuff, need visual relief. They need to be able to get away from where they are and expand their field of vision, psychologically as well as physically. It keeps people more relaxed and improves their mental attitude a great deal.
Did they have the experience of comparing their own emotions against installations like the Cummins Diesel office?
I didn't hear the question.
The Cummins Diesel office, in which the building is essentially buried, the top of it is a parking lot, but it does have open, a view on one side of the building.
Yes. The response of the Cummins Diesel plant, I believe, is a little bit different. There they had an enormous landscape that they could modulate by moving earth. As I recall, it's quite isolated by itself in the countryside. We did not have that luxury, and between the requirement for parking cars, the setback requirements imposed by the city, the size of the building itself, and the nearness of the side lot lines, we just could not bank up on one side to save energy and then arrange people's spaces on another side so as to provide the views that they would require. I think a manufacturing facility is slightly different than an office kind of facility also. It might be equally desirable to have views for the employees in a manufacturing plant, but there I think you run against the sheer functional logistics of having operations that occupy enormous spaces and just not being able to do maybe everything you might really want to do. We felt that we could give it a better shot by using glazing and doing this, pulling the building out of the ground a little bit. Yeah.
How did the possibility of having active solar collectors affect the design of the mechanical system?
I'm a little stuck on that one. The question was, how did the possibility of adding solar collection in the future affect the design of the mechanical system we have now, which of course has to take care of the whole building without any support. The perimeter, as I said, of the drafting room, virtually the whole building, is without radiation at window surfaces. We all know that that's a good way to make a space habitable, and it's the normal place that supply of tempered air, conditioned air is made. We did not do that in this building in anticipation of eventually being able to supply that need with the hot water that we got from the collector bank. The other aspect, perhaps, if we talk about tempering the air as it's drawn in through the fresh air intakes, we find that we will be adding, heat coils in the intake air ducts to do that tempering. Ditto the return ducts from the occupied spaces. The air will be taken over exchange coils, exchange radiation devices, and then taken in past a thermostat in the duct itself before it enters the air handling unit, so that the reading on the air taken into the system will occur after it's had the heat exchange, after it's been taken over these exchange coils, and then it's put through the building and then brought up to whatever level or taken down again, as needed. Yes?
Did you have an alternate design that did not have include the raised portion of the roof for the solar collectors? In other words, is there any way that you could compare the design that will accept the collectors, accommodate the solar, versus the same design without solar? Compare the cost of the building. I mean, just from a cost standpoint, or other than the design consideration, but right. The cost.
Yeah. I don't believe that we did that. I think that from the beginning it was intended that the building would have a major part of its design dependent upon a passive solar response. I think that was always anticipated. We wanted to experiment with the qualities of light and passive solar design, and then also use. We saw a very, very, what should I say, organic response between the organization of the monitors and the installation of the plate collectors. I don't really think that we had any anticipation of not doing a passive kind of study. We've kind of agreed among ourselves, I guess, that if it doesn't work out, we'll go back in and seal over put a ceiling across the drafting room and revert to a fairly standard sort of interior space. At that point, what happens to the monitors is moot. We don't anticipate doing it. We kind of like it the way it is.
Did you make allowances in your mechanical heating and air conditioning space for your mechanical room? Did you make allowances for retrofitting with solar, such as tanks and controls and
Yes, we did. Yes, we did. Yes, the mechanical room is located, I don't know if you remember from the slide, but it's on the west side of the building underneath the drafting room. It's quite large. And in that area, we would anticipate putting any storage tanks that we might, that would be required for a plate collector system. It's a very large storage room also under that side of the building, and if from changes in technology or whatever might happen, we find that we need more area, we can expand that way into the storage space. It's a kind of flexible area there where we have quite a bit of room to grow. I will, thank you. Yes?
I understand correctly, you have done an alternative economic analysis between your approach and conventional approach. How would you approach a client if, for example, you were going to propose advancing total versus conventional?
Just barely, but I think I got it. The question was, if we have not done a comparative analysis on this building between the conventional approach to heating and cooling using fuel sources available to us, how can we compare it then with the solar response of the building to the same problem? Do I read you right? Okay. We have an enormous backlog of experience in other buildings. You know, we've done a lot of buildings in the same area of about the same size and type in the last 25 years, 15 years, 10 years, 5 years. And we felt that we could rely on the response of those buildings, which has the benefit of being a little more more lengthily projected in history than our own building is. And we would rely on that backlog of experience to compare to other standard energy source responses. Did I see a question? One more? I guess not.
If I make a comment to the people who are speaking after us, there's some problem in monitoring these microphones when these are on and that one is on because they are taping this presentation. So if you're speaking from the podium mic, please speak up. Thank you very much.
Thank you.